Hello students, you're welcome to my class today. In our last class, we discussed something about applications to kinematics. I believe we did justice to that concept of integration. But in today's class, we're going to be dealing with area under the curve, particularly a curve that appears both above and below the x-axis on a Cartesian plane. I want us to quickly watch a video that explains this concept of integration. Make sure you pay rapt attention and take note of every question that you have. I'll be right back.
Complicated question because we've got part of the graph above the axis and part of the graph below the axis. So we can't do this question in one go. The reason is this green area here, that will give us a negative answer. So below the axis, it will give us a negative answer. And this purple area here will give us a positive answer. So if we try to do it all together, it would cancel out. So you'd have the positive bit take away the negative bit. That's not what we want. We want all of it together. So whenever we've got a question like this with part of the graph above the x-axis, part of the graph below the x-axis, we need to do two separate bits. So we need to work out the area of the purple section, the area of the green section separately, and add them together. So let's go through this question. So the first point is we need to find the points where the graph crosses the x-axis. So it crosses the x-axis when y equals 0. So we'll make y equal to 0 first, and then we will solve it by factorizing. So we'll factorize out an x first, and then we'll put the bracket into two separate brackets. What multiplies to make 10 and adds to make negative 7? That would be x minus 2 and x minus 5. So where does it cross the x's? It crosses at x equals 0, x equals 2, and x equals 5. So we've got 0 here, 2 here, and 5 here. So to find the area, the total area, the area of the shaded region, we're going to do two separate questions almost. So we're going to do the area in between 5 and 2, and separately we'll do the area between 2 and 0. So let's integrate this. So we're going to add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power. And of course we can simplify that. So we'll go x to the power 4 divided by 4 minus 7x cubed over 3 plus 5x squared. And that will be between 5 and 2 in the first instance. So we'll substitute in 5, substitute in 2, and take them away. So I've got 5 to the power of 4 over 4 minus 7 times 5 cubed over 3 plus 5 times 5 squared. Take away 2 to the power of 4 over 4 minus 7 times 2 to the power of 3 over 3 plus 5 times 2 squared. So we're going to type that into the calculator, see what we get out. and we should get minus, because it's underneath the x-axis, so we've got minus 63 over 4. Now, we can't have a negative area, so we don't write the minus, so it's 63 over 4 units squared. So that's the green section, and then we're going to work out the purple section as well. So it's exactly the same thing, but instead of being between 5 and 2, it's going to be between 2 and 0 this time. So we've already integrated, we don't have to do that again. But this time we'll substitute in 2 and 0, take them away, and see what we get out. So if we type that into the calculator, we should get 16 over 3. So I haven't written out it's substituted in, so I will do that. So we've got 2 to the power of 4 over 4 minus 7 times 2 cubed over 3 plus 5 times 2 squared minus 0. And then that should give you 16 over 3 units squared. So to work out the total shaded area, so we're going to add the green bit to the purple bit. So we've got 63 over 4 plus 16 over 3, and that gives us 253 over 12 units squared. Okay, another question here. So we've got, firstly, find the points where the graph crosses the x-axis. So it crosses x when y is 0. So 0 equals 4x minus x squared. We're going to factorize it. X 4 minus x. So x equals 0 and x equals 4. So we've got 0 and we've got 4. Find the area of the shaded region. So if we work out the area under the curve this time, that's going to give us this blue area here. So the shaded region is going to be, well, this square here, take away the blue area. So the area of the square, so we've got a square, which is 4 up, 4 along. So 4 times 4, that's going to be 16 units squared. So we're going to work out the area of the blue area, the area under the curve, and then take it away from 16. So we've got the integral of 4x minus x squared between 4 and 0. So first step, we're going to integrate. So add 1 to the power, divide by the new power, and add 1 to the power, divide by the new power. Between 4 and 0 this time. So we're going to substitute in 4. Substitute in the 0, and we're going to take them away. So we type in the calculator, so that gives us 32 over 3 units squared. But that's the blue area, remember? So the shaded region is going to be 16 minus that answer, which is 16 over 3 units squared.
Yes. Welcome back. I hope you enjoyed the class. Now you have fully understood what we mean by area under the curve. And that's one of the applications of integral calculus. till we meet again. I see you in my next class. Thank you. Take care.